Okay, so here's a question for you. What if the key, like the real key to confirming the Big Bang, was hiding right at the very edge of the universe, just sort of waiting?
Intriguing. Where are you going with this?
Well, get ready for this because astronomers using the James Webb Space Telescope, they've made this, well, they're calling it a groundbreaking discovery.
Ah, I think I know what you're talking about. The really old galaxy.
Exactly. They might have found the oldest, most pristine galaxy ever seen. And this isn't just, another dot on the cosmic map.
No, not at all. If it's what they think it is, it could be huge.
Right. It could be a fundamental missing piece in understanding how the universe actually began, providing really compelling evidence for the
Right.
Big Bang Theory itself.
Absolutely. A potential window right back to the dawn of time.
Okay, let's unpack this then.
Let's do it. It's genuinely exciting stuff.
So this galaxy, it's got a name, MRE6, and the distance is just staggering. We're talking over 13 billion light years away.
Which means, just to clarify for everyone, the light we're seeing now, it left that galaxy more than 13 billion years ago.
Yeah, exactly. So we're seeing it as it looked just, what, about 900 million years after the Big Bang?
That's the estimate, incredibly early in cosmic terms. It's like looking at a cosmic infant.
And that makes it, well, apparently profoundly different from pretty much anything else we've ever observed.
That's the crucial part. What makes Amora 6 so potentially significant is why it's different. The researchers, they suspect it could be a very rare zero metallicity galaxy.
Zero metallicity. Okay, break that down.
Right. It essentially means it might be a true fossil from the cosmic dawn, a relic from that very early time when the universe was just starting to build things.
A fossil from the cosmic dawn. So what does that actually tell us about the Big Bang itself? How does it connect?
Well, okay, think about the Big Bang Theory's core predictions, or the very early universe. Right after the bang, the universe wasn't filled with all the elements we see today.
Right, no oxygen, no carbon, none of that heavier stuff.
Exactly. It was almost purely the simplest, lightest elements. Hydrogen and helium. Plus, maybe some tiny, tiny traces of lithium. But that's basically it.
So all the heavier elements, the metals, as astronomers call them.
They hadn't been created yet. They had to be forged later inside the cores of the very first stars. Stars born from that specific, pure, untouched mix of primordial gas.
And those first stars have a name, right? Population 3.
That's them. Population 3 stars. Purely theoretical, mostly, because they would have been massive, lived fast, and died young, seeding the universe with the first heavier element.
Okay, but here's the catch. The thing that's always been a challenge.
Finding them, or finding galaxies made only of that primordial stuff.
Yeah. No one has ever found a galaxy that seemed to be made purely from that original hydrogen-helium mix. It's been this, key prediction of the model.
But completely elusive in observations. We see galaxies enriched by later generations of stars, but not the originals.
Until, perhaps now. And that's what makes Amory 6 so incredibly interesting.
Exactly. If it truly is metal-free, it's a game changer.
So, okay, this thing is unbelievably far away, presumably very faint. How on earth did they even manage to spot it, let alone figure out what it's made of?
Ah, well, they used a pretty neat cosmic trick. It's called gravitational lensing.
Gravitational lensing. That's where massive objects bend light, right? Like a lens.
Precisely. You get a huge galaxy cluster, something really massive, sitting between us and the distant object. Its gravity is so immense it actually warps space-time around it.
And that acts like a magnifying glass.
A natural cosmic magnifying glass, yeah. It bends and, crucially, amplifies the light from whatever's far behind it, light that would otherwise be way too faint for us to see.
Wow. So they found a convenient cosmic lens pointing at Amory 6.
Essentially, yes. The team, led by Takahiro Morishita at Caltech's IPAC, they used the gravity of a foreground galaxy cluster to boost the faint light from Amory 6, enough for the James Webb Space Telescope to pick it up and analyze it.
And what did that analysis show? What was the big reveal?
Well, this is where it gets really shocking, actually, when they looked at the light spectrum from Amory 6.
The spectrum, that's like the fingerprint of the element. Right?
Exactly. Each element absorbs or emits light at very specific wavelengths, creating unique lines in the spectrum. And they looked for oxygen, which usually has very strong, very clear spectral lines in galaxies.
Yeah.
Nothing. Absolutely no trace of oxygen where they expected to see it.
No oxygen at all.
Well, none that they could detect. And that absence is huge. It's a massive piece of evidence.
Why is the lack of oxygen so significant?
Because oxygen is one of the first heavier elements created by stars. If it's missing, especially in a galaxy this old, it strongly suggests that significant star formation with, normal stars hadn't happened yet.
So it implies the galaxy is pristine.
Extremely pristine. It means Amor 6 could be one of the only galaxies ever found with near zero metallicity, as clean, elementally speaking, as the universe is supposed to be right near the beginning.
Wow, okay. And this was all detailed in their study.
Yep, their 2025 study, I think it's called Pristine Massive Star Formation Caught at the Break of Cosmic Dawn, really lays out the evidence.
Okay, so stepping back from the amazing science of it all, why does this matter? Like for us understanding the universe, what's the real impact here?
Oh, it's fundamental. This isn't just like ticking off an item on a checklist. This could genuinely be the first population third galaxy we've ever directly observed.
The kind of galaxy everyone knew should exist based on the Big Bang, but couldn't find.
Exactly. Before AMR 6, these things, population third stars, metal-free galaxies, there was theoretical necessities, predictions, but we lacked the direct observational proof.
So AMR 6 isn't just fitting the model.
It's potentially the first concrete evidence that the model's starting point was correct, that these pristine structures actually formed. It basically helps close a major gap in our cosmic story.
A gap between the Big Bang itself and the more complex galaxies we see later on.
Precisely. It gives us a tangible anchor point right back near the beginning. It shows us, possibly, how the very first stars and galaxies got going. It sounds small, maybe one faint galaxy.
But it shines a light on the birth of everything.
Couldn't have said it better myself. It connects directly to how everything we see today eventually came to be.
That journey is just mind-blowing when you think about it. Starting with just hydrogen and helium.
And ending up with stars, heavy elements, planets.
Galaxies, life itself, it all had to start somewhere.
And AMR 6 might be showing us that somewhere.
Okay, so let's just quickly recap the core idea. We have AMR 6, this incredibly distant, potentially metal-free galaxy.
Seen as it was just 900 million years after the Big Bang.
And its lack of oxygen strongly suggests it's one of these pristine first-generation galaxies predicted by the Big Bang theory.
Offering really compelling direct evidence for that theory and filling a huge observational gap, a window into the cosmic dawn.
Amazing. It really makes you wonder, doesn't it? If the universe is finally starting to give up secrets this old, thanks to tools like Webb.
Yeah, what else is out there?
Exactly. What other fundamental mysteries are just waiting, maybe just beyond the edge of what we can currently see or understand?
It feels like you're peeling back layers, doesn't it? Each discovery opens up new questions.
It definitely does. One thing seems clear, though, when it comes to actually exploring the cosmos and its origins.
We're really just getting started.
Absolutely.